2 and looking at examples where we need to use a Roman numeral in the compound's name. So the steps are pretty similar when we've gone from a formula to a name. So the first thing is to match each partner's symbol to the correct name. And as you know, don't guess. If a partner is an element, you can find that information on table S. And if a partner is a polyatomic ion, you have your table E. So the big thing here is step 2. Now, if your cat ion, the first partner is located somewhere in groups 3 through 12, more than likely it's going to need a Roman numeral in its name to indicate which oxidation number it's using in that compound. So we will use a reverse crisscross method to figure out the value of the Roman numeral. And then the last partner, the second partner's ending. If the second partner is an element, you have to adjust or change its ending to the IDE. If the second partner is a polyion, just use the table E name. Okay, so let's take a look here at what we have. So we have a chemical formula, MnO, no polyatomic. So Mn, when you go, which we know here is manganese, and O stands for oxygen. So we would never say manganese oxygen, but we would adjust the oxygen and replace the YGEN with the ide. So we would say manganese oxide. Now, when you go and look at manganese, Mn, on the periodic table, okay, you will see that it has a +2, it has a +3, it has a +4, and it has a +7 oxidation state. So that means that manganese, it requires a Roman numeral in its name to indicate which one of these 4 oxidation numbers it's going to use. So we have to figure out a Roman numeral. So a reverse crisscross method. So we have Mn and we have O. We have the formula, so we know that there's one Mn and there's one O. We have to look up this guy's oxidation number. And when you look it up, it's second, so it must be an anion. The only choice is a -2. This is our unknown. So when you do the math, right, you have 1 times x plus 1 times -2, which gives you a -2, and they have to equal 0. So the question is that what would you substitute in for x so that the sum would be 0? So would you substitute in a 2, a +3, a +4, or a +7? Or you could just solve for x. So x equals +2. So when we go and solve this, the best fit is this guy here. So, and that equals the Roman numeral. So since the manganese is using a +2 charge, then our Roman numeral is Roman numeral 2, because Roman numeral 2 means +2 charge. So take a look at the next example. We see that we have the same elemental symbols, Mn and O. So we know that this is manganese oxide. It's some sort of manganese oxide. But when you take a look, the ratio between the two chemical compound formulas is different. Here we have a 1:1 versus a 1:2. So once again, we know that the manganese has a +2, it has a +3, a +4, and a +7. So we'll utilize a reverse crisscross. So we have our Mn and O. Mn subscript is 1, O's is 2. O is the anion, so we know its charge is a -2. Now we got to figure out which one of manganese's charges is being used. So here we go. So we have 1 manganese times whatever positive charge will work, equals, now we have 2 oxygens, they each bring a -2, so the total negative charge here is 4, and it has to equal 0. Solve for x. So x has to equal a +4. So in this second case, this manganese here, the best choice is its +4, and that's going to equal the Roman numeral. So it's manganese, Roman numeral 4, oxide. Okay, taking a look at another example. We have Fe, open parentheses, OH, close parentheses, 3. So right away, because we have these parentheses in the chemical formula, that's a big clue that this is a polyatomic ion. So we go to our table E. So our second partner, according to table E, it is known as hydroxide. Fe being an element, we can find its name on table S, and this is iron. And when you go and find iron on the periodic table, it is in the transition grouping. And when you take a look, it can use a +2 or a +3 charge. So we need to do a reverse crisscross to figure out which oxidation number is the Fe using, so we know what Roman numeral to put in the name. So here we go. So we just simply put, we have Fe, and we have an OH. Fe's subscript is 1, OH's is 3. Being the anion, we look up its charge, and it's a -1. We are trying to figure out which of the charges or oxidation numbers is the Fe iron using. Well, we only have 1 Fe, so it's just going to be X, right? We have 3 OHs, they each bring a -1, so plus a -3, and it has to equal 0. Well, which value would you substitute in for X? So when you add it to -3, it sums to 0. So our best choice here is that X is equal to the +3. So this is iron, Roman numeral 3, hydroxide. One more example to take a look at. So right away we see Pb3, PO4, 4. But we see those parentheses, which is a big clue for us, so we know that we have a polyatomic. So right away, we can go to our table E, and PO4 is known as phosphate. Now, Pb is not on table E, so we know it's an element, so we go to table S, and we know its name is lead. When you go and look at Pb on the periodic table, you will see that it has multiple positive oxidation states. It can either use a +2 or a +4. So we need a Roman numeral in this name to indicate which lead cation is actually in use here. So we'll use our reverse crisscross. So we have Pb, and we have PO4. Now subscripts, we know we have 3 Pb's and we have 4 of the phosphates. We're not sure which oxidation state the Pb is using, so that's our unknown. PO4 uses a shared charge of -3. So just do a little math. So we have 3 Pb's with the unknown, so that would be 3x, plus we have 4 phosphates that each carry a -3 charge, so that's a -12, and the sum needs to be 0. So solve for x, right? So x would equal +12 divided by 3. So in this case, our unknown, or what we're solving for, the best choice here is the +4. And that equals the value of our Roman numeral. So this would be lead 4 phosphate.